Hi everyone, my name is Connor Tulluck. I'm a solution architect here at Nearmap, and today I'm going to be talking about Nearmap's content stack and exactly where this data can be used in the engineering and architecture space. Prior to me coming over to Nearmap, I actually worked as a design engineer at a civil firm, and so I really view our content stack through this lens of how do we offer all of Nearmap's product offerings and maximize value in the design space, reduce risk, reduce cost, and fundamentally offer an enterprise solution across the U.S. footprint for some of our enterprise type clients who have data needs not just in their own local sector but across the entire company. Nearmap can really offer the scalable solution for providing this data across these many different offices. So I'm going to talk about kind of who Nearmap is as a company, what we do, where we fly, and then also get a little bit more specific into that data stack discussion of where can we use that Nearmap content, how do we integrate with third-party platforms, and how do we really maximize that value. And then I'll show up some CAD and GIS examples. So Nearmap, who are we? We are a aerial imagery company. We collect data through our fixed-wing aircraft. What we do is we actually have a proprietary camera system. We mount this system to the belly of a fixed-wing aircraft, and this aircraft flies between 8,000 and 12,000 feet, taking source photos of the ground at about 2.2 inches of resolution. And then we also take these source photos, stitch them together, and through the process of photogrammetry, we create a suite of 3D products that include things like point cloud, reality mesh, digital terrain models, and things like this. And then our newest product offering is now our vector AI. So what we do is we run machine learning on all of our vertical imagery, and that lets us conduct ground feature recognition, so find things that our clients might find interesting. So things like asphalt, concrete, impervious surface versus impervious versus pervious surface, different types of vegetation, things like building footprints, utility data. So we find things like manhole covers and utility poles, street lights, power poles, things like this. And this list is always getting longer. And all of this data is being vectorized, so being defined as points, lines, and polygons. And what that means for engineers is that this can be used to conduct not only more of a data analytics focus of doing feature counts and quantity assessments very quickly and in an on-demand fashion, but also doing things like generating CAD line work, right? Since all this data is defined as points, lines, and polygons, it can very easily be formatted into things like drawings that can be overlaid on top of our imagery and give your engineers a way to jump quickly into project design. And I'm going to be showing examples of all of this a little bit later. So I mentioned I was going to be talking about high-level Nearmap. That's kind of the overview. We are headquartered out of Australia in Sydney. We've been flying in the U.S. since about 2014. And again, we are always capturing. So we're doing up to three to four data updates a year in these highly urbanized areas. And I'm going to show a coverage map in a little bit as well in the next slide. So I think it's important to understand kind of what sets our technology apart. At its core, our patented camera system is something we heavily invest into. Really focusing on how to best optimize in terms of how high we're flying, so what altitude we're able to capture at, which lets us expand our coverage footprint, while also maintaining very high resolution. So around that 2.2 inch ground sampling distance, that's very key in terms of getting the most value out of the imagery, while also not flying so low that we are sacrificing on that coverage footprint. Focusing on accessibility of our data. So all of our data is stored in the cloud ecosystem and hosted on our web app, as well as a variety of different APIs. So really focusing on making sure that our content is easily accessed and making sure that it is processed in a quick fashion and delivered to clients on demand. And then also I mentioned a number of our other products really, and that's kind of what this video is about, is that Nearmap is more than just aerial imagery, right? That we are offering a comprehensive data stack that includes fantastic high resolution imagery, but also great 3D data that can be used in a design ecosystem, as well as vector AI data that's really taking that next step to making squeezing maximum amounts of value out of the imagery, and really allowing that imagery to play in the CAD environment and the GIS environment without having to do much work on the user's end. A couple of other updates here, that currency that I mentioned, the fact that Nearmap is always up to date, offering up to those 4 captures per year. It's consistent in formatting. This is actually extremely important to the engineering discussion of not having to piecemeal solutions data needs together. So having to deal with different file formats, different projections, CAD, Autodesk versus Bentley types of 3D integrations, and having to convert those. Nearmap is offering a fundamentally consistent and scalable solution for this data acquisition process. And then also that it's a no-fuss solution. We're focusing on ease of integration through investing into these API endpoints, and also the usability of our web product map browser. So this is our coverage map I mentioned. This is just our U.S. footprint. Again, we do capture in Australia. That's our home, our headquarters. So we have very comprehensive coverage of Australia, as well as parts of Canada now, which can actually be shown in this map a little bit. But focusing on the U.S. footprint, you can see we cover a lot of the major metropolitan areas, with some rural captures as well. Sometimes surprising clients that we do actually go to some of these smaller towns that you might not expect. But fundamentally, we focus on populated areas where we can generate the most value for the most number of clients. So this is a kind of a bird's eye view of our content stack. I think it's important just to have it on one slide here to show kind of comprehensively what we're able to offer. So again, our bread and butter is really that top-down, high-res vertical imagery, finding that balance point between great resolution and great capture coverage footprints. What we actually do on top of that vertical imagery is we actually, our camera systems capturing what we call oblique imagery. So this is about at a 45-degree angle from the aircraft to the ground. And what we do with this oblique is that it actually offers this additional perspective. So things that you might not be able to see from that top-down angle, you can generally see from the oblique. So things like building facades, kind of underneath building overhangs, kind of seeing around highway overpasses, things like this that might be slightly obstructed from a top-down angle. In addition to just giving more value to the capture footprint, we actually use these oblique images to generate all of our 3D products through photogrammetry. So it's actually a very important part of our data acquisition process. Our panorama product is actually just our oblique imagery that we stitch together into a tiled map. And then that tiled map can work just like a normal top-down web map, where the user can pan and scroll and zoom and check their site out without being restricted by the boundaries of a source photo. Our Nearmap 3D I mentioned a little bit earlier. Again, we use the process of photogrammetry to generate things like reality mesh. That's what's being shown in this slide, is that photorealistic 3D mesh that you can overlay designs on top of for proposal renderings and things like that. We also generate a 3D point cloud in a LAS format, and then we also have a digital terrain model, a digital surface model. These are raster data sets, so you can think of them as essentially point data that CAD GIS programs can read to set elevations of existing grounds. You can use them for terrain models, do things like cut fill analysis, profiles, cross sections, and I'm going to show them some examples of that a little bit later on as well. And then finally, our Nearmap AI product is our vector AI. So this is really taking that spatial intelligence, defining all of these ground features that you can see visually and doing it automatically, and serving those up on demand as our clients may have need for them. Super quick on this slide, just integrations and map browser. So again, our core product is our map browser web app. This is where we host all of our content, make it accessible for viewing. We have measurement tools. We have a time slider so you can see historical change over the duration of your project. And then we also have export tools so you can export different 3D data sets in a variety of different formats, reproject things, get them into your local machine, all very, very easy to use and pick up. And then we also really invest into these APIs, integrations, right? So having things like web map services, various APIs that can automate workflows and provide solutions at scale for these companies that are doing work across the country. And have needs for 3D, have needs for imagery, have needs for spatial analytics from the vector AI data. All of this can be very quickly automated and plugged into existing workflows. So this is really the most important slide, in my opinion, to kind of show why Nearmap is needed in this engineering space. What does the current data acquisition space look like for engineers, right? So think about an enterprise type company doing work across the country, across different locations in the U.S. with different DOTs who have different kind of ways of doing things, contractual requirements, things like this. During early phase of design, a lot of times these firms don't have good foundational data sets to start working and making go, no-go decisions, or creating very preliminary plans up to 15-30% completion. So the current solution in a lot of cases is to multi-source this data acquisition. So to work with DOTs to leverage existing data collection, work with local government, work with maybe some free data sets like USGS, and piecemeal things together. So pull high-res imagery from one place, reproject it to the correct state plane that they need. And that needs to be done by a GIS professional usually. Generally, when I was a designer, and I didn't handle that. It was usually one person that would spearhead that data acquisition process. Also, maybe piecemeal a 3D data set from somewhere. Maybe use some USGS to get an existing ground. Again, start to struggle with things like the data of acquisition, quality projections, and then maybe even use the DOT for some GIS line work that can start to form some sort of polygon definition of some assets that are existing, or maybe a center line data set. And really what happens when you do this is you create data gaps. Depending on the scope and the need of the project, you may end up finding types of data you need. You might find imagery, but you might not have 3D. You might find 3D, but might have very outdated or incorrectly projected satellite imagery or something. You're going to deal with these inconsistent accuracy standards and reprojections, file format issues. So a case where you may be working in an Autodesk system, but you want to leverage a Bentley mesh. I think a lot of times it's a common experience to see how much that struggle can really come into play. Trying to reformat this 3D data can be a bit of a struggle. And it's really difficult to scale the solution, right? So one data acquisition process that works in Connecticut and actually could provide a foundational data set from this multi-source approach won't work in California, for example, right? You're not going to have the same data providers that can provide for those same building blocks in the same repeatable way. And really, this is where Nearmap can come into play, right? Nearmap is a scalable solution across these enterprises. We can provide the starting, high-res imagery, 3D content, and vector content that can get your engineers up and running, making decisions about preliminary design, doing proposal renderings very quickly, getting CAD line work set up quickly. Everything's out of the box, reprojected in a way that you need, and again, it's a scalable solution. And it's on demand. It doesn't require any tasking of resources. And really focusing on the fact that it is cheap, right? This is a building block of how Nearmap conducts itself, right? Is we are collecting content and spreading out that cost to multiple clients, which lets us keep costs way down. And then this is kind of an image of what that would look like in the CAD ecosystem. So these are screenshots from Bentley. And really it's these 3 building blocks to get up and running on a project and start making design decisions. Having a high resolution aerial base map, this is a core component to having a continuous data set that you can really confirm. I mean, I know a lot of engineers spend a lot of time using ortho images, jumping into things like Google Map, just to supplement the data that they already have, especially on projects like design builds, which are picking up steam over the last few years. These jobs go on for 2 or 3 years, and a lot of times they're highly dynamic work sites. So having an up-to-date ortho image to justify design decisions as you're going back and forth with the designer and the builder is critical. The 3D data set is critical to have something that's up to date. As you know, a lot of design decisions can be make or break from that third dimension, right? So a highway that's being proposed on a horizontal plane might work great, but once you start applying the profile analysis, that design might no longer work. So as well as mitigating cost. One of the highest cost items on a highway job, for example, is going to be the earth excavation. The cut fill analysis is generally one of the top 2 or 3 costs. So having a good 3D data set can make the bids a lot more competitive in that space, and actually win more work, as well as really manage that risk more effectively. And then again, our AI data is absolutely fantastic. It removes that step of having to leverage a GIS professional to digitize a lot of this ortho imagery, and provide this line work out of the box, as well as provide data insights in terms of quantity analysis, conducting something like a count of how many utility poles are on site, how much of a spatial element is being impacted by design. You can run this a lot quicker and automate it. Again, it's the power of offering a scalable solution. Once a cost saving has been implemented in one office, it can be implemented throughout an entire enterprise organization. So that's really what I wanted to cover today. I appreciate the time, and thank you very much.